Today we're going to do a quick proof of concept OpenGL ESP for Assault Cube. We recently made this video teaching you how to do a trampoline hook, which we used our internal Assault Cube hack as a base. We added a trampoline hook to it. Then we made these two videos, which then added OpenGL drawing to that hook. So we're going to take this source code from this video and we're going to add ESP to it. So here it is right here. All I've done right now is added an assaultcube.h file. And what we're going to do for that is we're going to go into our reclass and we're going to generate the C++ code and we're going to copy and paste that in. What that looks like is this. So basically we need the entity and we need the entity list, okay? And from the entity we need their position and their name and then their head position as well. So those are the two things you need. We also need our weapon object because that's part of our reclass. So we'll just add that in. We need to include some headers, windows.h, and we need to include geom.h as well. And so let's add a new header as well. So we need to include algorithm so that we can get square root and stuff like that. And I'm just going to paste in this vector class. This vector class is actually by Fruit Smiles, and it's a really good one actually, so I'm now using that. It has operator overloads, right? So you can use plus, divide, minus, subtract, and that kind of thing. And then vec4 is the same thing, just with an added w, and that's used for matrix math. And then I'm just using the type alias to, this is just a little trick I use because I end up helping so many people with their source codes, and I'm always combining my source codes with their source codes that I just do this. And now it doesn't matter what type of vec they use, I'm going to override it basically with mine. You may run into issues with that, so make sure you know what you're doing. We're also going to add world to screen function, and that's going to be vec3 position, vec3 reference screen position, and then we're going to do float matrix, a 16 float array for that, and then in window width and in window height. If you're not familiar with world to screen and view matrices, we have a ton of tutorials. You just need to look on the website. So we only need to define one function here, and that's a world to screen. So let's go back here and let's add another file. And this is just going to be geom.cpp. And then here we're going to include geom.h, and we're going to include windows.h. And then we're going to paste that in and add the function body. We're basically doing matrix multiplication, a matrix vector product. And so we're going to use vec for clip coordinates. Anytime you're using a matrix, you're going to be using with a 4 variable vector. And so clip coordinates is going to be clip coords.x equals pos.x multiplied by matrix 0. And then we're going to add pos.y times matrix 4 plus pos.z and multiply that by matrix 8. And then we're going to add matrix 12. And then we're going to copy this 4 times. And basically, we're doing OpenGL, so it's going to be in this format. And again, all this is explained on our website, so just go check it out. But basically, this is matrix multiplication. That's what this is. You can look up that formula online. I think the best place to find it is on the OpenGL website. Here is the forum thread that teaches you everything about it. Literally everything you could ever want to know about view matrices and world to screen is written here. One of the links in the thread shows this link, matrix vector product. That is exactly what we're doing here. The whole function is what's called a transformation pipeline. So we're transforming from 3D world space into 2D screen coordinates. And so this is that formula that we're just coding right now. So after this, we need to check clip coordinates W, because if the W is less than 0.1 F, then they're either inside of you or behind you. And so you don't want to draw any boxes of people that are behind you, right? Then we're going to do vec3 NDC. And we're going to do, these are called normalized device coordinates. Basically what we're doing here is called perspective division. So we're dividing each clip coordinate by the W value. So ndc.x equals clip coords.x divided by clip coords.w. Paste 3 of those, and we just change it, y, z, z. After this, we're going to do screen.x equals window width divided by 2 multiplied by ndc.x, and we're going to add ndc.x plus window width divided by 2, and then screen.y equals negative window height divided by 2 multiplied by ndc.y, and then we're going to add ndc.y plus window height divided by 2. And then we're going to just return true. Yeah, so we do true or false return because if they're behind you, we just want to return. We don't want to draw them. And otherwise, we're going to return true that everything went fine. So now let's go back to DLL main and let's just look. We're going to get rid of, we had this like sample output we were going to doing some examples. We're just going to get rid of it. We're going to get rid of everything between setup ortho and restore GL. And basically we are going to draw our ESP here. So it's going to be like ESP.draw. And so we need to define our ESP class. So we're going to add a new class, and it's going to be called ESP. And in here, we need to include some files. So we're going to include assaultcube.h. We're going to include GL draw. We are going to include GL text. And then we have some things for scaling. This is a method I came up with, so it'll kind of like work universally. So constant int virtual screen width equals 800. So whenever I'm hacking a game, I'm using it. I'm doing it when I'm developing my hack. I'm using windowed mode with the screen width. I'm doing 800 by 600 as my resolution. So as long as you hack every game using a specific screen width and you define it here, you'll define a couple other variables and then it will do the scaling for you. So game unit magic. This is a number that is going to be different for every game because the units are different. So let's say the distance between you and the enemy is 10. Well, 10 what? Like, yeah, we know it's a float, but what does the game use? You know, some games use meters, some games use feet, some games use cubes. But really, are these real representations of feet and meters? We don't know. So we don't know what a game unit is. But so this number you're going to change in each game so that the boxes scale properly for you. That's the idea. So the next one is going to be player height equals 5.25f, and this is something I reversed from the game. Player width as well. So these are going to be different for every game. The aspect ratio for the player is going to be about the same, right? Because all humans have the same basic height and width in comparison to each other. And so eye height is necessary because we're going to subtract the eye height from the eye position to get the bottom of the players because we want our boxes to scale with size. That's the whole point of this. So the last one is going to be player aspect ratio equals player height divided by player width. And then we have, this is for our ESP text. We're going to do constant int ESP font height equals 15 and constant int ESP font width equals 9 because we are using Consolas font and that is the size. So again, if you're making your own ESP and you're using different things, you'll have to modify all these. But as long as you modify these things, you don't have to modify the actual formula that we're going to be using. So all you do for every new game you hack, you just change these things and you're done. Class, our ESP class, there's a million different ways to do everything. This is just something I ripped up real fast for this video. So this is going to be int pointer game mode equals, and I'm actually going to paste these in here. These are all addresses we've reversed in previous videos. You can find these posted on the forum and you can find them easily yourself, right? A game mode is going to be, is the game, are we in team deathmatch? Are we in capture the flag, etc.? So you can actually grab this from the Assault Cube source code. So I'm going to paste that in right here. These are the different enumerators for game modes. You would have to normally reverse these yourself. Luckily, we have a source code, so that made life easy. Basically, is it a team game, a CTF game, or a deathmatch game? Those are basically the three things you need to know for different types of hacks. Number of players that are currently in the game. We have our matrix pointer, and then we have int viewport. And this is just something specific to OpenGL we're using. But the third and fourth variable in this array is the window width and height. So that just makes it an easy way to get those. We don't need to reverse anything else. We're just going to use the OpenGL method to get that. So now we got a couple of variables for drawing our ESP boxes. So bool is team game, bool is enemy, so that we can do the correct colors, and we're going to pass in an pointer named E, and we're going to do bool is valid ent, and this is going to take a ent pointer ent. And then we have void draw ESP box. That's going to draw the individual box for each entity pointer. And then we are going to pass in the screen coordinates for that, and then the GL font reference. And then we have void draw GL font address font. We're just passing that in because we've defined that separately in our original source code. And so then we need to define these. So let's grab those addresses or those definitions. Let's grab those declarations, and then let's go over to ESP CPP and paste those in. Once you've fixed those up, let's start coding them out. So this is going to be our checking if it's a team game. So we have a game mode pointer, and then we have our different enumerators right there. And so basically we're just checking the ones that are for team games. And if it's any of them, we're going to return true, else we're going to return false. Is enemy, we're going to do if local player team equals e team. Then we're going to turn true, or actually we're going to turn false, and then else we're going to return true. Then valid ent is going to be if ent vtable equals. This is basically how we're figuring out if this is a valid entity pointer, because the vtable pointer is going to point to the vtable for a bot or a player, okay? A multiplayer player or a bot. Those are the only two things that can be. So if this pointer is just pointing to junk memory, then these will not match. This is a kind of ghetto. It works perfectly, and it's never been a problem. You're probably going to want to find a better solution if you're working on a different game, though. Return true. And if not, we're going to return false. Oops, we need to add an address here. 0x4e4a98. So if it's not the vtable address that we know that never changes because game never passes, we're just going to return false. So now drawing our ESP box. We are going to define a constant GL ubyte pointer named color, and just going to set it to null pointer. Then we're going to do if is team game and is not an enemy, then we are going to set the color to RGB green. And this should be a E, not a P, lowercase a. And then so if not, we're gonna set the color to RGB red. So if it's team game and they're a teammate, green, otherwise red. For enemy, if it's a regular deathmatch game, everyone's just gonna be red. Then we're gonna do float distance equals local player position dot distance e position. So that's going to get the distance between us and them. Ooh, this is supposed to be vec3 screen. I don't know how that happened. So float scale equals. So we got our distance, right? Now we need to scale the location of the box using that distance. So this is my little magic formula I came up with. And don't knock this. It works perfectly. And it's awesome. So game unit magic divided by distance. And then we are going to multiply it by viewport 2. So that's the third variable. So that is the width. And we're going to divide that by virtual screen width. So by using that, dividing it by the virtual screen width, we're getting a scaling factor that's going to match to the game's current window, okay? And then we're going to do float x equals screen x minus scale, float y equals screen dot y minus scale, and we're going to multiply that by player aspect ratio. So that's going to get the vertical of the box into the right location. And then we're going to do float width equals scale times 2, and float height equals scale times player aspect ratio, and then multiply that by 2. And then we're going to do GL draw outline, and we're going to pass in x, y, width, height, 2.0f, and color. Let's write all this code and then I'll explain it. It's going to make more sense that way. Text x equals font dot center text x comma width string length. We're going to pass in e name of the entity that we're going to draw, and we're going to multiply that number by ESP font width. Then float text y equals y minus ESP font height divided by 2. And then we're going to do font dot print, and we're going to print it at text x text y color, and we're going to put in our var string here %s, and then E, and then the name, and that's going to draw our name text. That's good. And now let's go in here, and we're going to do GL get integer v, and we're going to pass in GL viewport. That's the object that we want to get, and we're going to save it into viewport. So we're just using the OpenGL API to do that for us. We don't need to reverse those. And then we're going to do a for loop. We're going to loop through the entities. So for int I equals 0, I less than the value pointed to by num of players. That's a pointer we defined earlier. And then we're going to do I++, can't type as usual. And in here, we're going to do we're going to do an if statement, if is valid and we're going to pass in our current entity. And so that's ent list ents I know what's going on here. Got that random thing there. So now in here, we're going to do ent pointer e equals ent list ents. We're just getting a little copy of that to make life easier to deal with. Vex center equals e pointer head, and then center dot z equals center dot z minus I height plus player height divided by 2. Vec3 screen chords, and then we're going to do if world to screen center comma screen chords matrix viewport 2 and viewport 3. Those are width and height respectively. And then in here in this if statement, draw ESP box, and we're going to pass in the ent, screen coordinates, and the font reference. We need to get rid of that. ESP undeclared identifier. All right, let's just go back and explain this, okay? So this is our main function here. Need to end that. So we're going to get our viewport, our width and height of the screen. We're going to loop through the entities. If the entity is valid, then we are going to draw them. But we're only going to draw them if our world to screen work, if that W value is correct, right? So this is only going to be if they're in front of us, because world to screen, if the W is less than 0.1f, it's going to return false. Now, what is this stuff? Okay, so I do a weird thing. I don't think most people do this. Most people start drawing from the top left and go counterclockwise. And so they do all their scaling related to that. But the way I draw is I draw from the center and I scale around that. So we are getting the location of the head, which is actually the eye position, okay? We're getting the eye position, the Z coordinate, and we're subtracting eye height. So now we're at the position of the feet. And then if you add player height divided by 2, you are now at the very center of the player. So my boxes scale around that, and so that's why we're getting the center here. Then when we do world screen, you know, if just his little head is visible or just his toes are visible, we don't want to draw him, right? We don't want to draw him if he's literally in the frame, okay? This needs to be a capital C. And then we're drawing ESP box, passing in the entity, screen coordinates. This got passed in by reference, right? So it's basically like the return value contains the screen coordinates of the entity here, and then we can send that into our draw ESP function, and we're passing in our font, which has been declared elsewhere. So let's go to draw ESP box. We explain these colors, and then we're getting the distance, and then this is my scaling, okay? So we're getting the X minus scale, so that's gonna put us to the left of the player. Screen Y minus scale times player aspect ratio, that's going to put us at the top of the player, okay? So let's look at this image real quick. So this is our screen, right? As you go to the right, X increases. As you go left, X decreases. As you go down, the Y increases. As you go up, the Y decreases. So if we have an object in the middle, which is the player, and we want to draw above him and to the left of him, right? Because we want to start drawing in the top left corner and then draw clockwise, we are going to subtract from the X and subtract from the Y. So that's exactly what we're doing here, right? And that scaling factor is how far we want to go to make our box the right size at the current distance. And then the width is just scale times 2, and height is scale times player aspect ratio times 2. So the width of the box and the height of the box is going to be the width and height of the player model approximately. It's not perfect. Ooh, looks like I got another typo right here. E name. And then we're going to draw our outline. So here's our little dude, right? Here is the center of his body. And then, so we are going to draw a box like so. So we're going to go minus on the Y and then minus on the X. And we're going to end up right here. And then, so once we do our draw box function, this is going to be the top left coordinate where it starts. It's going to then draw to here. It's going to draw to there. It's going to draw to here. And then back up and finish the box. Once the box is drawn, we want to draw the text, right? So in the last video, I showed you how to make the center text function. We're basically telling it that we want to draw text in this area right here, okay, above the guy. So here's the box we're giving, and we want to draw in that box. That's what we're telling it. And we need the length of the string, so we need to take the number of chars in the string and multiply it by the font width, which we know. And so to draw above the box, we need to do y minus something to get above it. And in this case, we're going to use font height divided by 2, just because that seems to work out fine. And it will scale a little bit with the size of the font, right? And then we're going to print. And if we look at the center text again, what it does is if the width of the box is larger than the text width, then we are going to center the text like inside the box, not overlap. But if our text width is bigger than the box width, then we do want to draw outside of the box and overlap both sides at an equal amount. All right, enough of that explanation. And then we print. It's just like printf, right? So now we need to piece this all together in DLL main. So let's go in here, and we just need to define ESP, and we need to include ESP. And then we are going to call ESP draw, but we need to pass in the GL font, which we defined right here. And so now, with luck, this should compile. All right, let's see what's going on. Vec3 redefinition of basic type. I know what's going on here. So we redefined vec3 here, and in our last thing, GL text, we defined it there. So we just need to delete that. We then need to do include geom.h here to make up for that. And now our data not found for world to screen. So esp.h needs to also include geom.h. Where's world to screen defined? That's funny, I spelt it wrong. Okay, world to screen. Let's go back and fix that there. Now we should compile. Unexpected end of file. We need the precompiled header. So include stdafx. I like to put my libraries before my local headers. And clip coordinates not found. Clip coords. Uninitialized local variable. Oh, you know what we forgot to do? X, Y, and then Z, and then W. Okay, now we should compile. Let's inject. And we instantly crash. We made another issue here. We need to do else return false. And we actually no else here. We're just going to return false. Last thing we need to do, we're going to redo this. Basically, we're going to have this timeout after 15 seconds, and then it's going to eject our DLL. We also have a little typo here, 2 typos. So we want to make sure we're passing in the reference screen here, and window width needs another W, and we can go in here and fix those. Window width. Now that should compile again. Gorgeous. All right, let's see. Inject. And it is working. There it is. Not bad, right? Pretty cool. I really hope you enjoyed this video. Again, guidedhacking.com/donate, patreon.com/guidedhacking. Please support us so that we can continue to make videos, and peace out.